So, short introduction of myself. I'm Kristel Beckers, responsible for application developments of fibers, filaments, and nonwovens at TotalEnergies Corbion, the joint venture behind the Lumini PLA portfolio. PLA, or polylactic acid, is a bio-based, sugarcane-based in the case of Lumini, compostable polymer, which can be used as a more sustainable alternative to conventional plastics, including in hygiene applications, which is why I was asked to have a bit of a review of that topic today. So let's start with why we would use Lumini in these applications and review the scale of the problem. Every single minute, an enormous amount of disposable diapers are thrown away around the world, creating staggering volumes of solid waste. In the European Union only, they already make up more or less 4% of household waste, which is in weight, so volumetrically, percentage are much higher. And those are mostly incinerated. Now, you might think, why not just switch to reusable diapers? And yes, reusables can dramatically reduce waste, but they also require major behavioral shift for parents or caregivers. And the reduction of waste versus increase of water and energy use complicates the actual sustainability picture. So the trade-offs aren't as straightforward as they may seem. So then, alternative materials with a better footprint, bioplastics perhaps. Progress is happening there, but it's slower than many people expect. So diapers are quite complex, multi-layered products, and changing the material isn't as simple as swapping one component for another because of a mix of technical challenges and practical constraints. So in the next part of the discussion, I'll walk you through what those challenges actually look like and share a couple of concrete examples of how companies are working to overcome them. To simplify the complexity of a diaper, I'd like to zoom out from all the individual layers and focus on the three main material components. With this, I make already the assumption that the rough design would remain unchanged, and therefore the three components will remain for these more sustainable versions. So these three main components of a diaper are always SAP, which is super absorbent polymer, fluff pulp, and polymers. They're each more or less 1/3 of the diaper. Each part may have its own route towards becoming more sustainable. For SAP, we see things moving forward towards bio-based SAP, exploring biodegradable options and improving efficiency. So we simply need less of it. For fluff pulp, improving sustainability is mainly about responsible sourcing, using certified or recycled fibers and reducing total pulp use through design optimization. The polymer component, which is roughly 1/3 of the diaper, is where things become more complex. And here we can think in three major directions, which can be possibly even combined. So first, we can think about recycled content. In principle, replacing polypropylene with recycled polypropylene or polyethylene with recycled polyethylene is technically straightforward, even though sourcing large, reliable volumes of recycled material remain a practical challenge. Second, we can think of bio-based alternatives, replacing fossil-based polymers with bio-based versions or other renewable materials. And third, designing for end of life. This is actually the most complex step because obviously the diaper is not only a polymer, it's also containing SAP and pulp. So recycling would mean necessarily splitting of these three components, as well as removing whatever the diaper has been filled with. And another option for designing end of life would be thinking of a fully compostable diaper. Yet this would clearly require a complete system change, not just incremental improvements. And a material such as PLA is quite interesting here because it could play a role across all three. So it's available in recycled content, it's obviously bio-based, and it's compostable. But reaching true circularity will require more than this material substitution alone. as again, you would need to think about the entire product, not just about polymer parts, as well as a full system to circularity, rather than just focusing on just the polymer parts. So that's where the complexity gets in. If we see the basic properties of PLA being bio-based, compostable, and recyclable, including advanced recycling back to the monomer, we see that these match those sustainable pathways of the polymer portion for the diaper. And therefore, transferring to PLA might be an interesting opportunity. In addition, PLA is processable through any converting technology compatible for thermoplastic materials, which is, of course, an additional technical requirement. If managed to replace the fossil-based polymer portion of the diaper, for that portion, the carbon footprint will be 85% lower when utilizing virgin PLA, or even carbon neutral or negative when incorporating 30% recycled Lumini PLA or more. What we've seen so far makes one thing clear: replacing polypropylene and polyethylene with PLA or even other bioplastics could be a very promising direction. But that leads to the obvious question: if the benefits are so strong, why are bioplastics still used only in small amounts today? And that needs you to understand more the complexities of the application development there. So, and of course, how these can be overcome, because they can be overcome, and that's what I'll show with some examples. So, changing one material for another is never as simple as just throwing it to the same machine and hoping for the best. Every polymer has its own chemistry and physics, therefore it has to be designed to fit the converting technology, the product performance needs, and even the chemistry of the master batches that support it. Same goes for hardware and master batches. Those three pillars are all interlinked. So material, machinery, and master batches are really interconnected and need to be aligned within the application development process. So you can't just drop PLA or any bioplastic for that matter into an extruder and expect it to behave exactly like polypropylene or polyethylene. So the hardware often needs small adjustments, master batch needs to be altered, and the material needs to be tuned for the process. And the material side is where we, as polymer producer, can make the biggest difference. That's why we've developed a dedicated nonwoven portfolio that aligns with the most commonly used converting technologies. So only minimal adjustments are needed. But even with a well-matched material, fine-tuning process conditions, optimizing hardware settings, and using the right master batch chemistry, those really remain essential for successful adoption of the product. And that's really why close collaboration within these parties is really important, between polymer producers, machine converters, and master batch producers. And when all these come together, we can really develop a product with performance for its intended application. And so this is really the complexity within. And if you solve this technical puzzle, then you still need to strike the other balance, which is matching customer experience and cost. And when all this comes together, that's when you hit really the sweet spot, where it's not just working, but you really make it ready for real world adoption. On the material side, we as TotalEnergies Corbion now offer a bunch of grades for these applications, both core and sheath grades for biospun, along with a newly developed meltblown grade. So this makes it possible to produce biospun or even SMS structures, which is spunbond, meltblown, spunbond, which are also used in hygiene. And those can all be used in hygiene applications, but obviously also in other nonwoven applications. And then the examples. So a good first step example of how bioplastics are finding their place in hygiene products is the shift towards bio-based materials that feel almost identical to what customers already know. And in practice, that means the user doesn't really experience the change. So the product looks the same, feels the same, but the material becomes more sustainable. So what companies are doing already today is replacing the polypropylene portion of a biospun top layer with PLA and swapping the polyethylene portion of the sheath of the biostructure for BioPE. And with those two changes, you cut down fossil-based content, improve the product's LCA, and clearly gain a marketing advantage. So for the customer perspective, actually nothing feels different in touch or appearance. Yeah, you're creating a more easy entry for bioplastics in the complex product these diapers are. So it's an easy adoption of bioplastics in hygiene, obviously still requiring, the machine and master batch adjustments, but the customer is not really experiencing much change. So that makes it easier. And another way going forward for successfully bringing bioplastics in those applications is really bringing together the entire value chain from the beginning, from raw material suppliers to municipalities that run nurseries to the composting facilities those same municipalities operate. So in this setup, the nurseries purchase the diapers that are both bio-based and biodegradable, and the municipalities collect them afterwards to be processed in composting facilities. And by coordinating all these players at once, the project has managed not only to produce diapers that meet full biodegradability standards, but also to close the loop. So the used diapers are collected, composted, and turned into fertilizer that can actually be used again. In that way, it's a complete circular system and a powerful demonstration of what's possible when every link in the chain works together. And therefore, I'd like to conclude with that. There is potential for bioplastics in hygiene applications. We've seen already some success stories with Lumini PLA in those applications. Technical challenges are there, yet they're solvable through design and optimization, with value chain cooperation accelerating the progress. And on that note, I'd like to finalize with pushing a bit the emphasis on that sustainability is a joint journey. Altering the fossil-based plastic portion of those hygiene products might only go faster when cooperating together. So therefore, this talk is also an invitation to partner up and work together on better solutions for all customers and generations to come. So if you're interested to know more, discuss more in depth, feel free to contact me through these contact details, and I welcome any question you might want to ask directly now as well.